Tekam sir, Professor Rajendra Prasad Das sir, Professor Uma Kanjilal ma'am, Professor Sumitra Kukreti ma'am, Dr. Shrikant Mahapatra sir, and Dr. Manroop Singh Meena sir. Our distinguished dignitaries, speakers, Dr. C.M. Nautiyal sir, Consultant INSA, New Delhi, Professor Sevaram sir, HOD Transport in SPA, directors, heads of various divisions, directors of regional centers, and dear colleagues. We are here to celebrate the National Technology Day. To start this webinar, I will request Professor Satyakam sir to give us permission to start the program. We will start the program by playing full beat.
जी, कार्यक्रम को आप आरंभ करें। बहुत बहुत धन्यवाद, शुक्रिया।
जैसे शुरू होगा।
Shekhar, please start the full beat.
ये जन जन का विश्वविद्यालय, ये जन जन का विश्वविद्यालय, सरल सुगम शिक्षा का आलय। जन जन का विश्वविद्यालय, जन जन का विश्वविद्यालय, ज्योत जलाए ज्ञान की, स्वाध्याय की, अनुसंधान की राह दिखाए वंचितों को, शिक्षा के अधिकार की। ना उम्र का कोई बंधन, ना बंदिश परिधि की, घर घर है बना शिक्षा का देवालय। यह जन जन का विश्वविद्यालय, जन जन का विश्वविद्यालय, जन जन का जन का मान सम्मान पहचान है। राष्ट्र का आह्वान है, वरदान है, अभिमान है। राष्ट्र का आह्वान, वरदान, अभिमान है। सर्व सुलभ सर्वोत्तम शिक्षा का है वाला, मुक्त और दूरस्थ शिक्षा का महाल। यह जन जन का विश्वविद्यालय, जन जन का विश्वविद्यालय, देश विदेश पटल पर भूषित, नवाचार से सज्जित, गुणवत्ता से परिपूरित, ज्ञान वाणी ज्ञान दर्शन, ज्ञान कोश से संचित, ज्ञान कोश से संचित, सर्वगुण संपन्न शिक्षा का हिमालय, शिक्षा का हिमालय। यह जन जन का विश्वविद्यालय, जन जन का विश्वविद्यालय।
Today, we are here to celebrate the National Technology Day. Actually, this National Technology Day in India is an annual event that is observed on May 11 every year. This is the day that is observed to commemorate the achievements and acknowledge the works of scientists, researchers, engineers, and teachers. It helps to remind the public about the scientific advancements made by the country. It is a day to celebrate the works of all the people who have contributed to the growth of the science. We in IGNOU are celebrating the Azadi Ka Amrit Mahotsav, and in this regard, we felt that one of the fields India saw a major growth and development after its independence is science and technology. With various advancements in the sector, India has climbed its way up in the list of countries that are potential superpowers in the coming future. India celebrates this day, May 11, as a National Technology Day because it was on this day in 1998 the country successfully conducted the famous Pokhran nuclear tests. In this regard, we have also decided to celebrate this National Technology Day, and we got its concept from the director NCID, Professor Om Prakash sir, and then we have discussed this with our Pro-Vice Chancellor, and they have guided in a way that how to celebrate this National Technology Day. So after their guidance, we have decided to conduct a webinar on development in science and technology since independence. And for this, we have requested our distinguished speakers, Dr. C.M. Nautiyal sir and Professor Sevaram sir. And with a very short notice, they have agreed to join us in this webinar. We are really thankful to you, sir. And with this, I welcome you all to celebrate this National Technology Day and to hear our distinguished speakers, and at the same time to express yourselves in the open forum as well. With this, I welcome one and all in this webinar. Now, I would like to request our director, Professor Ashish Agarwal sir, to deliver his address.
Thank you, Dr. Shweta. Respected our BC, Professor Nageshwar Rao ji, respected PVC, Professor Satyakam ji, Professor R.B. Das ji, Professor Umakant Lal ji, Professor Sumitra Kubreti ji, Professor Meena ji, all our Director of School of Studies, Head of the Divisions, Regional Directors of Regional Centers, Directors of Centers, and my colleagues at School of Engineering and Technology. I welcome and our guest, Dr. Nautiyal sir and Professor Sevaram ji. Sir, I welcome all of you on this day, the Technology Day. As Dr. Shweta rightly said, we got this inspiration from our PVC Satyakam sir and Dr. O.P. Sharma sir, Director, National Center for Innovation and Development, NCID. So, Dr. Shweta has already told that this basically this Technology Day is remind us that how on this day we have joined the group of allied group with our nuclear power. Now on that day India become a nuclear power. So in 11th May 1998, the India conducted 3 nuclear tests at the Army Pokhran range under the Operation Shakti. So then it was decided that from May 11, 1999 to celebrate this day as Technology Day. And basically this day reminds us how our country, how our Indians, how our colleagues, how our senior scientists and researchers are making the developments for the country. So there are a lot of development which happened after the independence of our country. If you just see that in what condition after the this dependence or the slavery of British rule, we were in what condition, and now where we are. That is the development in the science and technology. And that is why under the guidance and the motivation of Professor Satyakam, we have decided to celebrate the National Technology Day. Our school, that is School of Engineering and Technology, is one of the 21 School of Studies of Indira Gandhi National Open University. Initially, we were engaged, we have developed several programs in engineering and technology, just like BTech Mechanical, BTech Civil, in Construction Management and Water Resource Engineering, Diploma Mechanical, Diploma Civil. We have also carried out several projects, just like projects for Army personnel, Diploma in Civil Engineering and Diploma in Mechanical and Electrical Engineering, Diploma BSc Nautical Science for Directorate General of Shipping, then postgraduate certificate in project management, and several other projects. Even for Footwear Design and Development Institute, we have carried out the project for 5 years, and we have developed and launched many programs in collaboration with Footwear Design and Development Institute. Now at present, we are running a few certificate programs, just like PG certificate in Industrial Safety, PG certificate in Inventory Planning and Warehousing System. Then we have MSc Renewable Energy under the NAP 2020 program scheme. Our school has launched. Dr. Shweta Tripathi is program coordinator for MSc Renewable Energy and Environment. Now, Diploma in Smart City and Management, Professor Sevaram has contributed a lot on for this program. Then we have a certificate in wastewater treatment techniques. Now we are in process of developing and launching BSc Applied Sciences, MSc Infrastructure Development Studies, BSc Industrial Safety. All these programs are in the pipeline, and soon we will be able to launch this program. At present, we are conducting all the student support service from our school only. We are providing the digital material to the students, and we are conducting the online counseling to our students. And we hope that this type of celebration, Technology Day, we will celebrate with the new theme, as the new theme for 2020 is integrated approach in science and technology for sustainable future. So that will be the theme for 2022 for the Technology Day, and that we will also conduct a seminar and on that day for that technology, so that it will remind us that what are the different achievements, what are the various achievements that our people has made for our country. Thank you, sir. Sir, may I now request our Honorable Pro Vice Chancellor, Professor Satyakam ji, who is a motivator for our school, and under the guidance we are able to launch this PG program and many other certificate program. Professor Satyakam ji is a very renowned personality in the area of Hindi Sahitya. His contribution is a very large contribution he has made in Hindi Sahitya. So, sir, may I request you, Professor Satyakam ji, to deliver the presidential address. Sir?
हाँ, आशीष जी, आपने ये कहा था कि पहले आप गेस्ट को कहेंगे। कल आपने मुझसे बात की थी,
उसको बात किया था। सर, उसमें क्या हुआ कि सर नौटियाल सर को सर जाना है,
हाँ,
इसीलिए मैंने फिर
तो नौटियाल सर से पहले उद्बोधन करा दीजिए। मैं तो यही हूँ। ठीक है सर। ठीक है ना? ठीक है सर। तो प्रेसिडेंशियल एड्रेस जो है वो अंत में ही होना चाहिए। ठीक है ना? तो नौटियाल साहब को जाना है, तो उनसे आप। ठीक है।
श्वेता जी, श्वेता जी।
हाँ सर, हाँ सर।
नौटियाल सर को आप हम लोग रिक्वेस्ट कर लेते हैं।
ठीक है, ठीक है।
Nautiyal sir?
Now it is the time for panel discussion. So our speaker, Dr. C.M. Nautiyal sir, has studied physics at University of Roorkee, IIT Roorkee. And during 1977 to 1985, he has finished his postdoctoral fellowship and PhD at PRL Ahmedabad as a collaborator for a study of NASA's lunar samples. He has researched in Earth planetary science and archaeology at BSIP and superannuated as scientist in charge Radiocarbon Lab, BISP, Lucknow. He is recipient of many recognition like International Travel Award by Meteorological Society USA. He has received INSA Medal for Young Scientist. He has also received Consultancy Medal from BSIP Lucknow and many more. He was member National Committee for Archaeological Sciences, convener of NSTC Network, and was on jury during 2 National Science Film Festivals and observed. He has organized many national, international conferences and events, and he is expert for many reputed organizations like DST, Vigyan Prashar, CSIR, UPCST, etc. He is well known for 850 lectures, 250 radio and TV programs, and more than 100 articles. Now he is working as program consultant, science communication to INSA, and secretary, UP Academy of Sciences, vice president of Vibhavat, chairperson or member of working groups and committees of UPCST, Vigyan Prasad, etc. Sir, I will request you to deliver your address as a panelist.
Thank you so much, Dr. Tripathi. Honorable Vice Chancellor, Professor Nageshwar Rao, Pro VC, Professor Satyakam, Professor Ashish Agrawal ji, and Dr. A.K. Sharma, it's O.P. Sharma ji. It's really a pleasure to be here and talking to you, the learned community of the country. And whatever introduction I just heard about the university from Professor Ashish Agrawal, I'm really impressed. Not that I didn't know about IGNOU. IGNOU is a very, very reputed institution, and it's a great joy to be amongst you people. Today, I am basically a scientist and not a technologist or engineer, but I have been an experimental scientist. I was in an institution of Indian Space Research Organization at Ahmedabad, the Physical Research Laboratory, which is the parent institution of the whole of ISRO. And therefore, that was a place where there was a lot of wedding between science and technology. If you look at the last 75 years of Indian independence, India has progressed a lot, both in science as well as technology. Before independence, we were totally dependent on the foreign countries for anything which required even a little of technology. We were totally dependent on food grain. In fact, the famine of Bengal is known in the history as one of the most serious famine. But then things changed, and it was not just because of science, but also because of technology. One thing I would like to say is that the definition of technology has also been changing with time. As we all know, initially, we all associated technology with machinery, equipment, and things like that. But ever since we had this biggest technology, IT, information technology, our definition of technology also seems to be changing. And this is not really something which is a tangible material, but this is the concept. It's in computers, it's in the hard disk. But this information technology has changed the face of our living style. It has changed the face of the world. We have been celebrating since 1999 the Technology Day on 11th May every year. And as has just been told by Dr. Tripathi and also by Professor Agrawal, and the reason was that in the year 1998, we had this Pokhran explosion, which was a cap on our achievements in terms of technology. But in addition to that, there were 2 other things that were accomplished on that day. One was, on that day, a successful launching of Hansa-3 aircraft was done, which was a 2-seater aircraft. Another thing was Trishul, a very successful experiment or the trial of Trishul missile was conducted on that day. And these three things meant a lot, and they were indicated to the future of technology in our country and how closely they are related to the well-being of the people, to the power to our armed forces, and to the defense of our country. So this day of May is remembered in golden, it's in our golden memory, and we always remember that as the Technology Day. And so this is why we celebrate it every year. Technology is actually the application of scientific knowledge to the practical aims of human life, or as sometimes it's said, to change and manipulate the human environment. Many people believe that we should do science because science leads to technology. And I would like to correct this wrong notion. It's not that always science came first and technology ensued from that. This is an incorrect notion. There are many examples in the history of mankind where technology came first and the science of that technology was learned much later. Take the example of the common thing, fire. We started using fire much before we knew anything about plasma physics. We started using fire. Similarly, we started using wheel much before we knew the relationship between circumference of a circle and radius of the circle. And there are many such examples. We were setting curd even before we knew what bacteria is. So the notion that science is important because it leads to technology is not really correct. There have been many instances where technology came before science, and we should remember that. Another thing I would like to be appreciated is that technology has more direct contact with our society than science. One example is, about 500 years ago, only 8 metals were known to the society. They were copper, zinc, tin, gold, silver, mercury, and lead, and iron. These were the only 8 metals, but subsequently, so much development has been made in the last few hundred years that we are using a number of metals as well as metallic alloys in our society. Aluminum was not known since about 200 years ago, which is one of the most used metals in the industries and in our society. So technology has really changed the way we live. And in fact, it has now started changing the way we think. And this is something which I will be dealing with in the coming 20 minutes or so during my presentation. I would like to start with my PPT. Are you able to? Yeah, so I hope that I can. Okay, I'll just do it again. I will just share a window rather than the whole screen. I think that's going to be better. All right. Always I think it's always a struggle. Sorry, I think it's taking a little bit time. A window. Why does it vanish? I think somebody has to permit me to make the presentation. Whosoever is looking after the projection, please just check.
Kindly open that file, PPT first.
Yeah, that is open. That is now minimized.
Now go to presentation.
Yeah.
Select entire screen. Select entire screen.
Well, okay, entire screen.
Presentation you are not one. Presentation, the तीन बटन जहाँ हैं जो डॉट्स हैं,
Yeah, I clicked on that.
पास में प्रेजेंट नाउ है, प्रेजेंट नाउ एरो ऊपर की तरफ लगा हुआ है.
Yes.
Just go to that arrow, present
Yeah.
now.
Your entire screen.
अभी आपका आया नहीं. You have not clicked on present now.
डॉट की जगह पे एरो वाले पे आ जाइए सर. जो
जी मैं उसी में हूँ, मैं एरो वाले पे ही हूँ.
एरो पे क्लिक करिए.
हाँ, क्लिक किया. Your entire screen, window, a tab.
और
Your entire screen.
मोटे साहब आपको होस्ट बना दिया है, आप कर सकते हैं.
Okay, now maybe it will. But I'm not getting the share option yet.
एक्चुअली सर वो पहले से आपको होस्ट बनाया. आप जब इंटायर स्क्रीन ओपन कर रहे हैं तो पीपीटी अपना ऑलरेडी ओपन कर लीजिए तो वो शेयर होगा. आपकी स्क्रीन शेयर हो रही थी और उसमें ये गूगल मीट वाला ही आ रहा था प्लेटफॉर्म.
हाँ, मैं अभी देखिए, अभी मैंने इसको खोला है पीपीटी को.
ये जो स्क्रीन है इसके नीचे जो एरो है,
हाँ जी,
जो हाथ का जो बना हुआ है इस तरीके से, उसकी बगल में एरो है
जी,
उस पे आप
मैंने
जाएंगे
किया
तो
है.
देयर विल बी प्रेजेंट नाउ.
उसमें वही ऑप्शन तो नहीं आ रहा. प्रेजेंट नाउ पे मैंने क्लिक किया. इट आस्क्स योर एंटायर स्क्रीन, अ विंडो और अ टैब.
एंटायर स्क्रीन.
They recommended okay, entire screen.
योर एंटायर स्क्रीन.
Yeah.
लेकिन हो नहीं रहा. हो रहा होता तो हमें दिखाई भी देता.
Yeah, because yeah, now it comes sharing, but
Yes, it is now coming. Yes.
yeah, but let us see what comes.
Now you select your PPT.
Yeah, I selected the
Go to your
PPT.
PPT. Open it and go to that slideshow mode.
I go to the slideshow mode.
Yes, it has now come. Slideshow,
It has
I think
come
it has come from first.
Now it's coming.
Yes,
Fine,
it is
fine.
visible.
Thank you. So I'll be talking about the science and technology and also the interrelationship, because I think it's very important to understand why we need a better wedding between science and technology. Science and technology are closely linked, but as I said, they don't always appear in the same order. It was not always that technology came first, came after the science. So often technology came first and science came afterwards. But the two have been in a very fruitful interrelationship. Technology has helped science. We will be discussing this, but in turn, science has also helped technology. This year we are celebrating, as you know, International Year of Basic Sciences for Sustainable Development. And the theme this year is that we should be appreciating that technology is important, applied science is important, but without the basic sciences, it cannot be used for the benefit of the society. So technology has to help science and science has to help technology. And I'll give you some examples where you would see that even some very, very basic science like nuclear or particle physics have been useful in development of certain technologies. And in turn, technology has been very useful in coming out with new ideas which have helped science, and we have been able to find new things, for example, Higgs boson or the God's particle. And I'll be giving you some examples from different fields. Humans are not new to technology. Even 30,000 years ago, stone tools were used. And this was before they knew that pressure can be defined by force divided by the area. They did not know the basic science, but they were using the stone tools. Similarly, they did not know anything about the momentum, the energy, and such concepts in basic physics, but they were using bow and arrow. And these things appeared something like 20,000 years ago in the Western Europe, as well as in the North Africa. Now we know where from the bow, from the arrow derives its energy. It derives its energy when we pull the string and that stored energy gets transferred when we release the string. It gets transferred to the bow. Bow goes and hits the target, and there, because it's pointed, it's the force divided by the area, which exerts a lot of pressure on the target, and the target gets damaged or gets hurt. Similarly, sling, more or less on the same principle, and sling and stone have been found in almost 700 years ago in the tomb of Tutankhamun in Egypt. So this is very obvious that technology came much before its science was known. So if we look at the history of the universe, which is supposed to have started some 13.7 billion years ago, the whole universe started with a big bang where the whole universe was initially concentrated in a single point. And that expansion, which started almost 14 billion years ago, is continuing even today. On the Nobel Prize, which was given about a decade ago, we also know that this expansion is unlikely to slow down. Many people were hoping that this expansion will start slowing down and ultimately the whole universe will start contracting, and this kind of oscillations will keep happening infinitely, but that is not the case because the recession is actually accelerating. So in finding these principles, the technology has been extremely helpful because the 3 degree, radiation, which is coming from all directions in the universe, was detected using this Horn antenna, for which Nobel Prize went to Arno Penzias and Wilson. Now, I must tell you one very interesting incident here. Arno Penzias and Wilson were working on it in the 60s, and they were constantly disturbed that the signal that they were getting always had a noise, and it was immaterial from which direction they got the signal. This noise was always there. They first thought that this was because of the droppings of the beats of the pigeons, but they cleaned the horn antenna thoroughly, but the problem still persisted. And finally, they realized that this was really a signal. This was not noise. And when they got in touch with their American counterparts, other universities, they realized that they had hit upon a very great discovery. And it was that this 3 degree Kelvin radiation was coming from all directions in the universe. And this was a relic from the early stage of the universe. And this told us about the expanding universe, or it supported the idea of the expansion of the universe. So we see here a case where technology came to the help of science. And similarly, there are many examples. I'll give you just 1 or 2 more examples, then I'll come to the science and technology in our country during the last 75 years. We know that medical science has a lot of equipments today. There are a lot of transducers which are used in medical technology, which detect some phenomenon, some action in our body and translate that into some kind of electrical signal, and we measure that or we count that, and that tells us about the condition of our body. Now, coming to physics, some basic physics. Those in the audience are from background in physics would perhaps appreciate that. We know that when a positron and electron meet, they annihilate, means both of them vanish. Vanish in the sense that their material is gone, they are converted into energy. This annihilation has been used in developing a very, very useful technology for cancer detection, and this is known as PET, or Positron Emission Tomography. The basic principle is, we know about cancer. Cancer means uncontrolled growth of body tissues, for example. Now, if more carbon and other elements and nutrition, etc., go to that part, then the other parts of the body are deprived of that. So this undesired, uncontrolled growth inside the body leads to a tumor, and this can be cancerous, it can spread, it can ultimately kill a human being. What positron emission tomography does is, it visualizes this biochemical change happening in the body. And the basic idea is that for we have more of, for example, carbon-11 reaching there. Now this carbon-11 this decays with a few minutes half-life. It emits positrons. These positrons come out of the body and they interact with the electrons in the atmosphere. And when positron and electrons meet, they vanish in thin air and energy is generated in the form of gamma rays. So what is done is, after injecting this radioactive isotope inside the body of the patient, that patient is slided inside a chamber which is actually a gamma ray detector. Now inside the body, when positrons come out, they interact with electrons, gamma rays are emitted, and the chamber detects from where these gamma rays are coming, and that tells us where there is cancer in the body of the patient. So this was a beautiful wedding which came to save lives of many people, and therefore PET is a beautiful technology. It can not only help in cancer, in heart disease and brain disorders, this also allows scanning, which is not possible by other methods like CT or magnetic resonance imaging. These cancer cells show up as bright spots on PET, and we are able to find out many isotopes of radioactive elements can be used, or elements like carbon have isotope carbon-11, nitrogen-13 is an isotope of nitrogen, oxygen-15 is an isotope of oxygen, and similarly F-18, an isotope of fluorine. These isotopes can be used, therefore, to detect the cancer in the body of a patient. This is the example of that image which you get after the tomography, and this tells you where in the body of a patient cancer is. So science has been helping engineering in technology, and technology has not been unfaithful. They have been very good friends, and they have returned very kindly to science by helping science detect phenomena which they were not able to detect earlier. For example, physics told us about the wave nature of light. We know it. We know that radiation has a corresponding frequency and wavelength. And if the frequency is higher, wavelength is smaller. If the wavelength is larger, then frequency is smaller. Which means if we cannot look at certain small objects under an optical microscope, we resort to scanning electron microscope, because electrons can have very high energy, and scanning with those electrons gives us images of very small objects, even bacteria and virus. You know that the virus during the past 2-3 years, the virus for COVID-19 or SARS-2, SARS-2 has been photographed using electron microscopy. And this is because my electrons can have very short wavelength, and they help us to look at these small viruses, which was not possible by any other technique. Electron microscopy had received a Nobel Prize. An interesting aside is that the work which, for example, Ruska did was in 1930s, and when he got the Nobel Prize, he was already close to 80 years of age, and he said that it's not important to do good work for winning a Nobel Prize. That is, it's not enough, but you also have to survive long enough, because if you don't survive, the dead people don't get Nobel Prize. So the physics of waves led to electron microscopy, but now we have seen that electron microscopy has helped us in detecting the quantum mechanics based microscope. Technology has helped us in the medical science by transmission electron microscopy pics of novel coronavirus 2. This is a photograph you can see. But another thing you would notice is that the image that we get from the electron microscope it's a two-dimensional image, for example, here, and this gives you the shape of that corona. It tells you that there are these spikes, and further analysis showed that spikes are made of S protein. S stands for spike, and this is critical to our process of development of vaccines for COVID-19, because this spike is attacked. If you can remove these spikes, the coronavirus will not be able to attach to the human body, and therefore we would be safe. So this microscope is a gift of basic understanding of physics, but when technology made it possible to construct this microscope, we were able to do many more things. Similar is an example of laser, and you look at Dr. Kalam here. Not only he was a president of India, but he was a great technologist. He worked in missile technology. He worked with the DRDO. He was advisor to the government and also president of India. Now, he gave a very interesting idea to the industry, and that was a good example where the basic knowledge about materials was applied for the human benefit. He said, we are using alloys for our missiles. Now, missile is a body which goes into space at a very high velocity. But when it goes to the atmosphere and when it returns through the atmosphere, it experiences very high temperature. So it has to be very strong. At the same time, it has to be very light. At the same time, it should sustain very high temperature. Now, if we have developed one such material for missiles, why can't we use that material for making crutches for the people who are suffering from polio or some accident? Because if you make crutches with such material, with such alloy, those crutches will be light, the crutches will not be rusting, and those crutches will be very strong. And that is history was made, and people started making crutches with alloy, which was actually developed for missiles. This was one example where technology came to the help of humanity. We know that almost 100 years ago, mass spectrometers were developed by Dempster and Aston. They were actually chemists. But now in our country, technology has come to this level that Bhabha Atomic Research Center, they have a section like Technical Physics and Prototype Engineering Division, and they have been able to make mass spectrometer in India. There are also private industry in the country who made mass spectrometers. Now, this is something why we say that technology in India has developed considerably during the past 75 years or so. Another very successful example of technology is the nuclear technology. India is committed to the peaceful use of atomic energy, but we have the capability to make nuclear bomb. Everybody knows it. This is a public knowledge now. But we are using it for nuclear energy, even though the total percentage of nuclear energy in the total bouquet of energy is just a few percent, maybe 2 or 3%. Although there are countries who are using almost 100% of nuclear energy for their energy requirement. But now India is establishing new reactors, and several 1100 and 1200 megawatt reactors have been established in the country last few years, and many more are in the process. But nuclear technology is one of the success stories in our country, and I'll tell about them a little more afterwards. But another interesting application of a technology I will tell you. You know about DNA technology or DNA fingerprinting technology. If there is a living material, it would have DNA. And that DNA can be found out, and those different objects can be identified. In fact, every human being has a different DNA. We share them from our parents, and if a small part of the body, it can be a part of a skin, it can be the nail, it can be some other part of our body, it can be analyzed, and an individual can be identified based on the DNA. In fact, if sometimes the body is destroyed, it's dismembered. For example, it happened in the case of the late Prime Minister Shri Rajiv Gandhi. Whatever was recovered was used to establish that the body parts were indeed of late Shri Rajiv Gandhi. Now there is the forensic department which applies DNA thing, but there is one more very interesting application of DNA, and that is to understand whether a rice being supplied is really basmati or not. Actually, the story goes like this. England was importing a lot of rice from India, and obviously that rice was a basmati. Basmati, as you know, has been derived from the word vas and mati. Vas means smell or fragrance, suvas, as they say, a good smell, good fragrance. And mati means which it bears that, and also it has a feminine connotation. So basmati is a rice which has very good fragrance. It has very good taste, but at the same time, it has one more very good property. When you boil it, that is when you cook it, its shape doesn't change much. Its length to its width ratio does not get affected. Whereas in case of other rice, they become fatter, whereas the length does not increase so much. Now, there were complaints from the importers from the United Kingdom. They said that the rice which is being supplied by our country has a lot of adulteration, and sometimes even 1/3 of the rice is actually not basmati, even though it looks like basmati. So the Indian scientists resorted to the DNA fingerprinting of this basmati, and now there is a standard procedure. There is a standard operating procedure that if you want to export rice that is basmati, you will have to get it DNA fingerprinted. A certificate will be issued, and you have to attach that certificate whenever you export basmati to any other country. So this saved our reputation, and this was a very interesting case where the technology came to the rescue of our national prestige. And therefore, based on that, it's only in the states of Punjab, Uttaranchal, Uttar Pradesh, Haryana, that basmati from these places, from certain districts, only is identified as basmati. And this has been done based on the DNA fingerprinting of basmati from those places. Another thing we know about radioactive decay, and you perhaps know, I was heading this laboratory at the Birbal Sahni Institute of Paleosciences at Lucknow, an institution of Department of Science and Technology. I will not go into too much details of carbon-14. All I will tell you is that because the radiocarbon or carbon-14, which is an isotope of carbon and is radioactive, every 5,730 years, it reduces to its half. Another 5,730 years, it reduces to a further half. So it goes on decreasing. And if we take a natural material like wood or charcoal, and the amount of radiocarbon concentration is half of what was expected, we know that it is 5,730 years old. This is something extremely important for archaeology. Today, when we are trying to find the age of our archaeological material, suppose we find an old temple or an old structure, and we find the wooden door of that structure, we would be able to use this technology for finding the age of that wooden piece, and therefore the age of that door. If we find old furniture, an old singhasan, which is made of wood, we will be in a position to find out how old that wood is, which has been used in making of that singhasan. So this is how it has been done. But you know, there was a constraint in the conventional method. We were not able to find the age of the sample if the sample amount was not enough. Suppose we don't have 2 or 3 grams of charcoal or wood, we won't be able to date the sample. But then came in 80s a technology by name Accelerator Mass Spectrometry, AMS in short. And now you'd be happy to learn that in our country, in Delhi, there is Inter-University Accelerator Center for Accelerator Mass Spectrometry. And that center in Vasant Kunj, they have Accelerator Mass Spectrometry functional. In Physical Research Laboratory, Ahmedabad, that is a place where I was earlier working, that place also has got Accelerator Mass Spectrometer. And Bombay University in Mumbai has also got Accelerator Mass Spectrometer. And this technology has made it possible to, for us, even if you have a painting, and the painting is very old, but the sample amount is very small, you would be able to date that sample. So this technology has really made it possible to date things which we could not date earlier. If you have a small seed from an old fruit like Sharifa, Sharifa has been discovered in several places in the country, in Sonbhadra district, in Mirzapur district, and also in Sanghol in Punjab. Now, the importance of finding Sharifa is that people believed, particularly the Western archaeologists, that in India, Sharifa was brought in the 16th century by the Portuguese. But many paleobotanists did not believe it. They said, in the temples of Mathura and other places, we have seen that there are engravings of Sharifa on the walls of the temple. So Sharifa existed in India even before the 16th century. But how to settle that issue? This issue was settled. This issue was settled when, using our method and also the accelerator mass spectrometry, the seed of Sharifa was dated, and it turned out that it was very old. It was about 3,000 years old, and therefore it existed in the country many years ago. Similarly, genetic technology or the DNA technology has helped developing new variety of rice. There are many engineers who have earned Nobel Prizes in science. There are about 30 engineers who have won Nobel Prize in science. That means the relationship between engineering or technology and science is really very close. Of course, 2 of them were for peace, but others were for chemistry, for physics, and other fields. Even in our country, Jahangir Bhabha, the architect of nuclear science program in the country, the founder of Tata Institute of Fundamental Research, he was an engineer who shifted to cosmic physics. Then he came back to India, to Indian Institute of Science, and later he established Tata Institute of Fundamental Research and also the Atomic Energy Commission. So in India, we have technologies. Now, nobody asks questions like, which is more important, science or technology? So in this year of International Year of Basic Sciences for Sustainable Development, we should remember that these 2 things are complementary. In India, we have many technology developed or adopted after independence during the 5 years. We made cryogenic rockets, we made nuclear reactors, nuclear energy, we make isotopes, and those reactors are also used in preserving food by irradiation. We have computers being made in our country. We have one of the biggest industries in information technology. We made Param computer, a supercomputer. In DRDO, we developed Arjun tank. We developed fuel cells. We developed BrahMos missiles, which could be fired from land, ship, and also aircraft. We have Akash missiles, which go from surface to air. We have guided missiles like Nag. We have Trishul, which was test fired in 1998 on 11th May. We have air-to-air missiles like Astra. We have DNA technology, and we now know that there is a close relationship between science and technology. For example, Department of Atomic Energy made the 32-meter antenna for deep space network for space science for ISRO. Components for Large Hadron Collider, which was instrumental in finding the Higgs boson or God's particle. Many of the parts were fabricated in India by the Atomic Energy Commission. Alloy developed by the DRDO for missiles was used for crutches for the people who could not walk because they were inflicted with polio or some other problem. DRDO's units developed aircraft. We know that on this day of 11th May in 1998, a 2-seater aircraft Hansa 3 was developed. In India, our own country, our hall of glory for some engineers, this includes a list. Professor Dr. Engineer Satish Dhawan. Of course, Engineer Satish Dhawan was, I would say, genius perhaps, because he was MA in mathematics, MA in English literature. He was an engineer and he was also a PhD. He was director of Indian Institute of Science at Bangalore, and later he chaired the space science department of the country. We have Dr. Engineer M.R. Srinivasan, who was also given Padma Vibhushan. Engineer Dr. S.P. Goel, who headed the Ministry of Earth Science. He was a Padma Shri. K. Madhavan Nair was an engineer. K. Radhakrishnan was an engineer. Engineer K. Sivan and Kiran Kumar. All these 4 persons were engineers who headed the Indian Space Research Organization. There are some engineers who were also scientists, like Hiroshi Amano and Shuji Nakamura. They were, of course, Japanese. They were engineers but won Nobel Prize. So in our country, we have proved now that rice also originated many years ago. And this was done using the technology of accelerator mass spectrometry. So we can see that technology has been helpful in science as varied as physics, technology, archaeology, and history, and many such. So in short, we can say that the science, engineering, and technology are closely related. They have helped each other in growth and refinement, but generally science lays the foundation of technology, but it's not always true. Many engineers have also been great scientists. In India, great strides have been made in space, nuclear, defense, biotech, computer, information technology, and many such fields. By closer interaction, science and technology both will be benefited. So thank you very much for this very, very patient listening. And I am very happy to have interacted with you. Thank you so much.
Thank you very much, sir, for giving us a true picture what India has earned in the since independence. You have given a very clear picture about the technology transformation that took place in India and in the world as well. Thank you, sir. With this, now I would like to request Professor Sevaram, sir, who is an alumnus of IIT Delhi and SPA Delhi as well. He is BTech in Civil Engineering from IIT Delhi, New Delhi. He is working presently as Professor and Head of Department of Transport Planning in School of Planning and Architecture, Delhi. Before coming to this academic, he has worked as transportation engineer as well in Navi Mumbai. His area of interest: transport design, transport infrastructure, planning and design of sustainable transport systems, etc. Designs, and he has been actively involved in formulation of several Indian Road Congress codes and or guidelines. He was leader of Transport Group for Technology Lead Assessment (TNA) for Habitat sector that became milestone for benchmarking for Paris Declaration. He was one of the member of the International Draft Committee of Formulation of Combined Resolution of United Nations Center for Regional Development. He was coordinator of Research Symposium Urban Mobility India Conference 2013, and he has been involved in several committees. He has been invited by internationally and nationally recognized bodies, IRF, IRTE, IRC, TRB, etc., and large numbers of university or institutes, including IITs and management institutions, for presentation related to transport planning and safe geometric design. He is involved in guidance of research and PhD on public bike share, accident costing, public transport safety, etc. Sir, now I will like to request you to give your presentation. Professor Sevaram, sir.
Thank you, Dr. Sweta. The first check, am I audible? Yeah. Hello.
Yes, sir. Yes, sir.
Is this slide visible to you? Hello? Dr. Sweta?
Visible, sir.
Visible, sir. Visible, sir.
Okay, okay, fine. Thank you. So, at the outset, I would like to be expressing my thanks to IGNO. And it is I would say, a consecutive day for me. And looking at the dynamism of IGNO, I am thinking that I should also be changing myself from Sevaram to Dynamic Ram. That is what I have understood. Just Seva is not sufficient. Thanks to Professor Satyakam, Professor Agarwal, Dr. Nautiyal, who I happen to listen, Professor Katie Menon, and Dr. Sweta, and all those who are able to make up from different RC from the different parts of India, and those who are attending this. I certainly after attending, listening to Dr. Nautiyal, I do not know where do I stand. That is always the first batsman is it's always the first actually, and he played a very nice inning in the beginning. So I am thankful. Interestingly, applied physics happened to be my area of interest also. I have also guided the several research which are interrelated with the physics. We used the principle of physics for congestion management. That was the concept of hysteresis. We used the principle of, he was using PET, but I used the post-encroachment time, that is for road safety, etc. So I'm discussing in a different parts, that is on Indus, that is, I'm first discussing how do we go into the technology right from the civilization that we call actually. I do not know how many of you have actually read Vedas or not, but I do not know. But if there is a lot of mentions in Atharvaveda, Veda, particularly that is 12.1.47, which mentions a lot of dynamism and lot of technological innovations which were for the roads. And it was that time that the concept of the different utility and different kind of the path and different kind of delineations of the road was made. This is what is actually mentioned. So if you look at Indus Valley civilization, there is enough discussions which you can take it. The first technological innovations that actually was greatly helpful for the mankind. After all, we have to look at how does it add to society. That's what our Honorable Minister also says, that anything that you do, whether it's science or technology or anything, should be connected with the people, should be connected with the society. So it was that time actually in that civilizations that different methods, whether it was related to irrigation or it was related to constructions of houses or it was related to drainage detailed system, etc. It was the urban planning, but what also the technology that was used in that case. If you just happen to see what are the major advances that have been made, the entire part actually, there is some disturbance coming from the backside. So this is of course tells you what were the phases that was, you could see how through the civilizations actually the interactions network of Ravi phase was actually taking place. You would not find any part which was somehow not getting connected through this. This is in a way that is a Google Earth view that you can look at it here. This was another integration area of 2600 to 1900 BC. And that you can again see that what are the major network and what was the, so what you learn from that, the civilizations was actually spread in a larger area than we thought. And this is the first, I would say, the sign that you started understanding of a planned so-called, you call city or you call a planned habitat. And it was the first of its kind where a lot of technological innovations were used at that time. The first came that they started having the mud brick walls, and that was around each major mound it was used. And it was then came the concept of the baked brick, etc. And then they started understanding how do they locate the concepts of elevations that started coming. They started even measuring the elevation. So technological tools for measuring the elevation also came at that time. You could see that how that is the so-called the 1 million cubic plus, that is water was passing through the so-called Sukur barrage at that time. You could see the picture now. And these are the picture that you could see how the villages on ancient mounds were above the flood level. So the first came the concept that you have to have an habitation which was above the flood level. So that is a very good sign of the habitat. And as I told you, not only for planning, but also even measuring the elevation, etc. came at that time. So this is what you learn from how the Mohenjo-daro mound was there, and this is Indus at the low level that you could see. Yes, this is how the molds that it was taking large time at that time. Now, since it was taking large time, they came with a new concept. How could they manufacture the large brick, etc.? They changed the size, they manufactured the block, etc. And the community and the mass block printing actually started coming at that time. And then came the concept of this brick, etc. They understood that it was heavy, so they started having that is less in weight. Again, I'm telling you how the technology was used even for redesigning, reshaping the brick, etc. So you could see how the walls actually were created at that time, and that is quite actually 4 meter high, 2.5 meter wide, and almost running about 1.5 kilometers. So it's a long wall at that time. When imagine there was no pillar, etc., but it could sustain the pressure of whether it's a wind or any earth pressure, etc. This is what you could see the pictures of that bonding, etc. It's a good picture that you could see it here, that which talks about how the locations of the two important discoveries of the silk. That is what became actually the guiding factor, and so we started understanding how the silk route, etc. were used. So that takes us that how the habitat actually started changing its shape, and how the plant network came, plant habitat came, the idea of the drainage systems came, the technology in constructions of the houses and material came, and that's how the first technology that was visible. After we understood that there was already a mentions of Atharveda, that is I told you, how the transport system has evolved over the period of time. We need to understand that had there not been a concept of technology, we would not have listened to each other today, what we are doing it today. Somebody asked a good question. Is transportation a must? It's difficult. We have always measured the growth, economic development on the basis of mobility rate. Earlier, we used to say more mobility rate is an indication of now we have started understanding that there is a concept of sustainability. There had to be mobility, whether it's a physical mobility or it is in the form of information mobility. If you can curtail some of the unnecessary travel by making the sustainable development, yes, that is what is required, but that is also a part of mobility. If there is no need to talk to you, I will not talk to you, that is there. But if I'm not invited because I don't possess those kind of qualities, etc. So that came from the position of educations to the experience to this. In a way, it is a sign of economic development. That is what we say. So, but otherwise, how we have started changing this, how the demand and supply pattern have changed it here. This was the previous transport technology. We had it earlier. I have already made one lecture in IGNO that I was a pleasure to deliver that. A part of that, of course, I already discussed how we started shaping our transport from the man oriented, from the zero energy consumption oriented to we have come back to again zero energy consumption, but in some other form that we have come in, that is there, okay? So we started understanding that there is a need to move fast. If we had not developed these fast modes of transportation, they would not have been what is the slogan of the present government and our honorable minister, connectivity. So connectivity, whether in terms of network or in terms of physical or in terms of man or in terms of society, it is only possible when we have a transport connectivity. And the transport connectivity, larger the speed, less will be the time for interaction and more you will be closer. It could be true that COVID-19 was also the cause of the faster mobility. Yes, that will always happen, the negative, positive attribute. But we need to understand what the positive attributes of a transport technology. We started moving from there, transport technology, then we started came the concept of the Maglev, magnetic elevated system. Recently, I have designed a Maglev systems that will connect to the proposal we are submitting to the government for even connecting to the Jewel airport. that is there. Already there is a discussions of high-speed rail, not discussions, that is in a project from HSR, and large number of high-speed rail transportation will come. What it will do, it will bring the settlements which are far away to a close distance. And what it will do, it will have the similar kind of impact what we have in Japan. You can be sitting in Nagoya and you can be traveling towards Tokyo in a very less time. So what it do, it will provide connectivity, and that's what is the need of the hour. That's what the technology should do it here. This is how you could see from the temporal change, how we have moved it right from the wheel and how we moved into this. It is again the different kind of evolutions that we have taken place in different modes of transportation, whether it's a air, road, etc. In the road now we have moved the different hierarchy wise, we have moved it in regional wise, we have moved to expressway. Now we started having the last, another hierarchy will probably be added, will be called super expressway, which will be designed at 150 odd kilometer. So is the case of rail also. If the HSR, that is the high speed rail, is coming, it is again to provide a faster connectivity. Yes, it is certainly faster and safe and in a reliable manner. That is also there. So came the concept of the rail and air. And as the economics grows, we also keep on shifting it from the public transport to the private transport. I was really reading a lot of doing reading because I'm writing one paper, how the transportation systems have evolved in the earlier time, and I am getting some citations even from Veda also. You would be surprised to know at that time there was a concept of public transport system. So this comes that when we are doing the technology not only in the case of private transport, but also in the case of public transport, also in the case of the affordable transportation system. This is how the different transportation system has evolved over the time. This is how the different, how we have gone in terms of the rail system, etc. Yes, this is the rail system that has evolved over the period of time. Then you could see there was locomotives, and then now we have come back to, I already told you that there is a lot of work being done in, it is this reasons why the China is getting faster connectivity even to inaccessible areas also. They are able to connect it here. The transportation does not lead, is not only confined to this, but we also have the transportation system for inaccessible areas. Yes, we could have electric roadway, and there are other modes of transportation systems too that we have got it here. This is how the system has evolved. What are the innovations that we have got it? The innovations right from 19 to 2000, that is what we have come all the way from that side. You'll be surprised that there was already a concept of the electric in way back in 1912. We are talking about there was a concept of electric starter, there was a concept of electric vehicle at that time also, but probably it could not take up the shape, and now we are getting back to the same only. I do have, this is how we were doing the presentations, and this was cited in what it was also taken by the government also, that we say that we should not be just confining to the electric vehicle, but also go back to the hydrogen fuel cell. Now the hydrogen fuel cell is talked about. We are saying that it is even better as compared to this. As Dr. Dotial was talking about, we are likely to have even the nuclear energy in the case of transportation systems, if it can be used in a safe manner. So there could be, as we prepare the document for technology need assessment for the habitat sector, and we prepared, in fact, all this, how the evolution, how the exchange, how the transformation of technology should go in the period of time. So this is what you get in terms of the vehicle ownership. You will get, it's a good idea that you could get it. We have a concept of that is incremental change. You go to the world of car sharing, that probably everybody says in India it is working or not working, but certainly it is working very well in the case of the hired mode, like the modes that is Uber or Ola, or there could be other mode also that is. So there is a concept of now going to come in terms of the driverless revolution that is going to come, and there is a new concept that's going to come in an accessible autonomy. That is what. And over the period of time, what you'll find out, the important thing, what will happen, you will have cost. The cost per mile that you will have will be very, very less. What are the potential effects of the shift to the future? There will be a lot of changes that is already taking place in the transportation system. It is the transportation systems that actually saved us and provided the relief, even in the case of COVID also. You could get your supply you could get your supply without physically traveling with the help of the communication, that is ICT systems, etc. also. So we do have, that is also considered as a parallel transportation systems and parallel communication systems. How the trends is going to change in the case of mobility. In fact, we will go from urbanization, yes, accident, loss of life, which is there, we have to save it actually. It's somebody is losing the life, losing the generations, and the country as such losing a lot. So that is very painful, cannot be reversed at all. So this is one, our objective is technology will help greatly in reducing the possibility of accidents that is there. God may not, if accident happen, it will also make you reach the desired services or the hospitals or trauma center in the least time. So come the questions of the technology. Yes, we do have environmental concerns, and we do have, that's how our technological innovations will take. What at the end we will get saving in the carbon footprint, we will get a lot of man hour will be saved if we can save congestions. We will save a lot of, you can convert into mental, psychological frustration you will get. And overall, we get a good that is called our connectivity, that is important. This is how the different parts of this, mobility system can be used, etc. This is a question that is coming up nowadays in a big way, and that is going to be the future technology. We will have a concept of connectivity. This connectivity will be in such a way that even the pedestrian will be informed, the information of a pedestrian crossing will be informed to the vehicle, and thereby, if even the driver is not doing this, it will be fit into the automatically the vehicle will either stop or reduce the speed, etc. So that is what probably the ultimate technology, where it takes into account providing the safety even for vulnerable users, be it pedestrians, this is how it can get connected to. Yes, we do have what are the connected vehicle challenges. Challenges are in terms of privacy or data security, and reliability is also there. That is one. Reliability, in fact, I wanted to talk about, has become a major part now. Technology is going to take place. When we refer to the Google map, at times it tells you 30 minutes, but is it really 30 minutes or 30 plus 5 or 30 minus 5? We are already working on one of the research to add reliability dimensions into that. Yeah, there will be some technological innovations will do. Now, next time what happens, if you want to select a route, it will tell that, okay, you select this route 30 plus minus 5. There is a route which is actually taking less time, 20 minutes, but the reliability could be not be so good. It will take 20 plus minus 20. So you will say that, okay, I don't want to travel. I don't mind traveling 5 minutes, but give me the reliable route. So that could be another dimension that is going to come in the time to come. This is how the autonomous vehicle, I will not be here. I will be on the top actually, but 2070, who will see when you will have a completely autonomous vehicle that you will see it here. This is how the autonomous vehicle actually this is the challenges that you will have connectivity, you will have, yes, it requires validations, assurance, everything will be there. It has already come. I don't know you have seen the Google vehicle or not. That is how the connected vehicle and autonomous vehicle, there is a difference between the two. But if you look at this is how indirectly this pedestrian is crossing. So what happened if you read it here? The information of the pedestrian goes, or the cycle goes to the vehicle it goes to the network, that network, that is the tower, and from there it again comes back to this. Both pedestrian as well as the vehicle will be alerted in that case. In fact, I spoke the last time also. I did work, design even the technological innovations for visually challenged system, how a visually challenged person could even cross using the traffic signals. I wish I could show that. That is. So this is, if you just see this video, that video will make you see how, yes.
It's time for a driving experience that is more fun, more efficient, and safer. Ericsson is making this happen, connecting cars around the world. Improve your driving experience by accessing the controls in your car remotely. Unlock or lock it from your phone, wherever you are. Have your personal settings on and ready for you when you enter the car. Listen to your favorite entertainment apps while driving.
Open App Store.
When you want something new, Download the latest music, news, weather, or other apps from your car's app store, just like you do on your phone.
Spotify.
And no matter where you're driving, you can stream without interruption, without having to rely on your phone or another device to direct you there, whether the road is changed or traffic is jammed. Traffic alert. Road closure up ahead. Maps are updated with real-time conditions, redirecting your route. You'll be intuitively and safely guided by your 3 screens, keeping your journey efficient and relaxed. Your car can help you find and navigate to available parking, and even let you pay for it by a touch of your screen. Simple and easy, whether in a parking lot, garage, or city streets. When you're ready to leave your parking spot, your car knows and takes care of the payment. A car that will run a health check and connect you to a service center before anything happens. You need an oil check. Would you like to book a time at a service center?
Yes.
You have time in your calendar on Thursday. Do you want to book it?
Yeah, let's do that.
With over-the-air updates. An update is available. Would you like to do it now while you are parked?
Sure.
From infotainment to engine management and cruise control, your car will be updated for better performance throughout its lifespan. And on safety hazards or important information coming up on the road, such as ice, potholes, school zones, or accidents, while still keeping driver information safe and anonymous. Warning, hazard up ahead. When you such as ice, potholes, school zones, or accidents, while still.
This has already come in the last number of vehicles already. The systems has come ourselves. I have already guided the work, and we are just about to finish the work on the artificial intelligence on parking demand management. We also developed the app, the technological app, which will indirectly the persons, if you are walking or you are driving on the roads, it will warn you about the hazard that you will likely to get it, whether it's a drainage, etc., or it is likely that you might have a collision, etc. We have used it. We also used these technological innovations in developing the bus safety risk index, etc. So time to wonder, a lot of work is being done in transportation sector, which is in terms of this. So this is the big data that is coming in a big way nowadays. That is another. And this is how that autonomous vehicle will look like, how the sensors, etc. We are not here to discuss but to sensitize you how technological innovations have changed the vehicle, have changed the information system, and overall how it is going to provide benefit to this. At the end, of course, our objective is to see that we achieve our sustainable development goals. That is an important part. You could see this house, the building, etc. design, which is our part, that we are able to meet all SDG goals that is being listed, and that is the basic criteria that we have got it here. These are, in fact, I made this presentation earlier, leaving the transportation side, coming to the habitat side. These are the buildings where already some innovations have been used. In each one of them has got some kind of innovations, whether it is in terms of the zero energy, or it is in terms of using the concept of the solar kitchen, etc. So there is already an innovations in all these habitat sectors that you have got it here. Yes, a lot of work is being done in solar panels, and this is how, again, I have just told about how if an accident has happened, the problem is that I was just examining the bad accident which happened just a week in the last week on Yamuna Expressway. Very sad to go on the field, and very sad to do the research. And believe me, the accident that has happened, it is purely because of there was a breakdown of the vehicle, and the breakdown could not be communicated to the vehicle which was driving. True, the vehicle was driven at a very large speed. The first of all, you should have controlled that speed. Now question comes, how could you have controlled the speed? If I'm driving at 80 km/h or any speed, that is what? First of all, there's a vehicle is already there, the alarm keep on playing. But through the cloud message that keep on making, you are driving fast, you will be prosecuted. This message will come, okay? If the message will come, I don't have a phone, no problem, then I will use my VMS, that is a variable message sign. If I have a variable message sign, it will warn me. A, it will warn me. B, it will let me be aware that there is a vehicle breakdown ahead. It will tell in lane 2 the vehicle breakdown has taken place. I do have the video to show how the vehicle accident could be saved if you do have this. But these are the emergency response systems actually you put through. The moment accident happen, you don't have to, certainly you should not make the vehicle to collide, but God may not, if accident happen, automatically with the bag opening, every message will start getting transported even to the nearest site. I'm already working with Niti Aayog to develop this kind of the work. And that is the work, paucity of time I will not discuss on. That is the work that we are working in advanced traveler information systems, whether it's a control systems in terms of the signals. Yes, signal, it has been used greatly. And finally, of course, we on India, because I would like you to see this video that is from the government side here.
The foundation of the modern urban metro rail system in India was laid in 2002 by the then Prime Minister Shri Atal Bihari Vajpayee with Delhi Metro. By 2014, it had expanded to 248 kilometers of operation as well as 411 kilometers of under construction metro network.
अटल जी ने अपने समय में काम किया, लेकिन अब हमें उसे आगे ले जाना है, हमें नई ओर ले जाना है.
India, a land of opportunities with immense potential, is on the path of building a new India with determination and conviction to fulfill the aspirations of its 130 crore people. Currently, 702 kilometers of metro network is operational in 18 cities, while 1,016 kilometer network is rapidly under construction in 27 cities. The development of metro network has ushered a wave of latest technologies, unleashing investment, generating jobs and business opportunities in the country. The tireless efforts made in the last 6 years have steered the country in a new direction of self-reliance, especially through skill development of workforce and the Make in The foundation of the modern urban metro rail system in India was laid in 2002. NCMC card, platform screen doors. India is rapidly moving towards self-sufficiency. A knowledge-sharing platform, iMetros, is helping in enhancing the efficiency of all metro systems across India. The development of metro systems has brought a socio-economic transformation of cities. In areas such as signaling, rolling stock, design, NCMC card, platform screen doors, India is rapidly moving towards self-sufficiency. A knowledge-sharing platform, iMetros, is helping in enhancing the efficiency of all metro systems across India. The development of metro systems has brought a socio-economic transformation of cities. Promoting the use of public transport resulted in less congestion and pollution, and with the use of clean energy, new cities are emerging with improved quality of life. The regulatory framework is being amended in the form of new metro rail policy to give a new direction to the urban development, increase the private sector participation, develop new sources of funding, reduce costs, metro rail network. By promoting holistic, sustainable and balanced development, the metro sector is now opening new vistas of opportunities and possibilities and playing a crucial role in shaping the new India.
Thank you. I don't think I should be encroaching the time of other speakers. Yes, this is slightly my apology for frequent interventions. I would be again expressing my thanks to it's an opportunity actually. When you get an opportunity, a teacher is always a hunger. That is the first criteria for a teacher is we are hungry to discuss, we are hungry to learn. And we are working for mankind. Otherwise also, I stand for Seva Ram. Okay? So I am for service to the mankind and learning lesson for me. Thank you, everybody. Thank you, Igno. And a very special thanks to our Vice Chancellor, Professor Satyakam. Thank you.
Thank you very much, sir, for this wonderful presentation. Now, as Professor Ashish Agrawal, sir, Director SOET, has already introduced our Pro-Vice Chancellor, Professor Satyakam, sir. But apart from it, I would like to say that sir is a wonderful guide and mentor, and he has prepared such a roadmap for our school that it is leading us to the path of success. And sir, your able guidance is something that we are quenching for. And sir, please deliver your presidential address. Thank you, sir.
धन्यवाद डॉक्टर श्वेता जी। आज दो वक्तव्य हम लोगों ने सुने, डॉक्टर नौटियाल साहब का और प्रोफेसर सेवाराम जी का। आज एक महत्वपूर्ण दिन है कि हम राष्ट्रीय प्रौद्योगिकी दिवस के अवसर पर इकट्ठा हुए हैं। और जैसा कि डॉक्टर नौटियाल ने बताया कि जो वैज्ञानिकों का योगदान है, उस योगदान को याद करने के लिए और जो भी हमारे देश ने प्रगति की है, उस संदर्भ में लोगों को प्रोत्साहन देने के लिए, ज्ञान और विज्ञान का विस्तार करने के लिए हम आज के दिन ये राष्ट्रीय प्रौद्योगिकी दिवस मनाते हैं। और जहाँ तक मैं समझता हूँ, आज का जो ये कार्यक्रम है यह बहुत ही उपयोगी रहा है और बहुत सारी ऐसी बातें और ऐसे तथ्य हमारे सामने आए हैं जिससे मैं दूसरों के बारे में तो नहीं कह सकता हूँ, अपने बारे में कह सकता हूँ कि मेरे ज्ञान की बहुत वृद्धि हुई है और मैं बहुत लाभान्वित हुआ हूँ। दोनों ही जो व्याख्यान हुए, उन व्याख्यानों से ये बात सामने आई है कि भारत में प्रौद्योगिकी और विज्ञान का बहुत तेजी से विकास हुआ है और हो रहा है। और हम लगातार आज़ादी के बाद से ही ये प्रयास कर रहे हैं कि हम आत्मनिर्भर हों। हम ये देखते हैं कि जो देश प्रौद्योगिकी और विज्ञान के लिए दूसरे देशों पर, और जो बड़े देश हैं जैसे अमेरिका है, रूस है, चीन है, फ्रांस है, जापान है, उन पर निर्भर करता है, जर्मनी है, तो वो एक बंधन में होते हैं और एक गुलाम जैसी स्थिति होती है कि हम छोटे से छोटे कार्य के लिए भी उनका मुंह जोड़ते हैं। और निश्चित रूप से हम वैज्ञानिक और तकनीकी और प्रौद्योगिकी के क्षेत्र में स्वतंत्र नहीं रह जाते। आज हम ये गर्व से कह सकते हैं कि बहुत सारे क्षेत्रों में और बहुत सारे मामलों में हम विज्ञान और प्रौद्योगिकी के क्षेत्र में आत्मनिर्भर हो चुके हैं। लेकिन बहुत सारी चुनौतियां हैं, उन चुनौतियों का सामना हमें करना है। और जितने भी हमारे वैज्ञानिक हैं, हमारे विज्ञान के शिक्षक हैं, हमारे स्कूल ऑफ इंजीनियरिंग एंड टेक्नोलॉजी के जितने भी हमारे साथी हैं, उनको इन दोनों व्याख्यानों से प्रेरणा लेनी चाहिए। हमारा विश्वविद्यालय जन जन का विश्वविद्यालय है और हम सब जानते हैं कि हम उन विद्यार्थियों को भी सुविधा देते हैं ज्ञान अर्जित करने की, पढ़ने की, अध्ययन करने की, जिनके पास कोई सुविधा उपलब्ध नहीं होती। तो हमारा जो स्कूल ऑफ इंजीनियरिंग एंड टेक्नोलॉजी है उसके पास असीम संभावनाएं, और अभी सेवाराम जी और नौटियाल साहब भी आर्टिफिशियल इंटेलिजेंस की बात कर रहे थे। हम बहुत सारे क्षेत्रों में आर्टिफिशियल इंटेलिजेंस पर काम कर सकते हैं, और अपने विज्ञान के जो की उपलब्धियां हैं उनको जन जन की भलाई के साथ जोड़ सकते हैं। अभी काफी लंबी चर्चा आदरणीय सेवाराम जी ने की ट्रांसपोर्टेशन सिस्टम को लेके, कंस्ट्रक्शन को लेके, सोलर एनर्जी को लेके, मेट्रो को लेके, और तमाम कंस्ट्रक्शन से लेके और ट्रांसपोर्टेशन तक सभी चीजों। और उन्होंने एक बहुत अच्छी बात कही कि अपने नाम के अनुरूप वे देश की सेवा में रत हैं और लगातार जो काम कर रहे हैं कि किस तरह से आर्टिफिशियल इंटेलिजेंस को जन जन तक पहुंचाया जाए। मेरा ये कहना है कि अभी तक ये जो आर्टिफिशियल इंटेलिजेंस है वो शहर केंद्रित ही रह रहा है। हमें इसको ग्रामीण क्षेत्रों की ओर और ऐसे क्षेत्रों की ओर हमारा ध्यान जाना चाहिए जैसे हमारे किसान हैं, हमारे मजदूर हैं, मछुआरे हैं, या फिर जो लोग जोखिम के क्षेत्रों में काम करते हैं। बहुत सारे क्षेत्रों में हम लोगों ने इस आर्टिफिशियल इंटेलिजेंस का इस्तेमाल कर लिया है। जैसे वेदर रिपोर्ट है इसमें, तो सैटेलाइट के माध्यम से अभी उड़ीसा में और बंगाल में एक तूफान आने वाला था, लेकिन वो छू कर निकल गया। लेकिन एक चेतावनी सबको दी गई, सबको मालूम हो गया कि एक तूफान चला है और मछुआरे समुद्र में न जाएं मछली मारने के लिए। और क्योंकि पहले ऐसा होता था कि जो वेदर फोरकास्ट होता था या तूफानों की सूचना होती थी, चक्रवात की सूचना होती थी, वो बहुत ही देर से मालूम होती थी और तब तक काफी नुकसान हो जाया करता था। आजकल हम देखते हैं कि ये जो आपदा आती है उसमें सरकार पहले से तैयार होती है, और आपदा तो होती है, अब तूफान आएगा, बारिश होगी इतनी तेज, तो नुकसान तो होगा, लेकिन जान माल का नुकसान अपेक्षित रूप से काफी कम हो जाता है। तो मेरा ये मानना है कि ये सारे जो आविष्कार हो रहे हैं, जो प्रयोग हो रहे हैं, वो आम आदमी के तक जरूर पहुंचने चाहिए। और सब लोगों के पास आर्टिफिशियल इंटेलिजेंस से युक्त गाड़ी नहीं हो सकती है, वैसे घर नहीं हो सकते। हम इसके बारे में हमें बहुत सोचना चाहिए। हालांकि जो मोबाइल फोन, जो कंप्यूटर से उतरकर मोबाइल फोन में आर्टिफिशियल इंटेलिजेंस आ गया है, उससे कई प्रकार की सूचनाएं होती हैं। अब किसी गरीब व्यक्ति को अगर अपने घर पैसे भी भेजने होते हैं तो वो मोबाइल से भी, ऐप से भी अपने पैसे भेज सकता है। तो ये जो ऐप का विभिन्न प्रकार के जो एप्लीकेशंस हैं, उन एप्लीकेशंस का जो आविष्कार हुआ है, मैं तो कहता हूं कि हमारे जो शिक्षक हैं स्कूल ऑफ इंजीनियरिंग एंड टेक्नोलॉजी के, वे भी कुछ ऐप बनाएं अपने अपने क्षेत्रों में। आप सिविल के भी इंजीनियर हैं, उसके लिए भी ऐप बनाएं। आप मैकेनिकल के इंजीनियर हैं, इलेक्ट्रिकल इंजीनियर हैं, एनवायरनमेंट के लोग हैं, तो आप लोग एक कम से कम छोटे छोटे ऐप बनाएं, सब लोग पेटेंट लें उसका। उससे न केवल हमारे विश्वविद्यालय का बल्कि स्कूल ऑफ इंजीनियरिंग एंड टेक्नोलॉजी को भी एक बूस्ट मिलेगा। क्योंकि देखिए हम एक सार्वजनिक और सामाजिक विश्वविद्यालय में, जिसका बहुत बड़ा सामाजिक उद्देश्य है, उस विश्वविद्यालय में काम करते हैं। हमारा काम केवल यूनिट राइटिंग या मटेरियल को डिस्पैच करना नहीं होना चाहिए। रिसर्च की ओर आप लोगों को आना चाहिए। मैं बराबर ये कहता हूं कि कुछ लोगों को प्लम्बिंग का काम सिखाओ, कारपेंटर को सिखाओ, लेकिन इन क्षेत्रों में भी आप, जैसे कि डॉक्टर सेवाराम जी ने कहा कि क्या आप आर्टिफिशियल इंटेलिजेंस को यूज कर सकते हो इनके लिए। अभी जैसा कि आप सब लोग जानते हैं, हमने अपने विश्वविद्यालय में सौर ऊर्जा का इस्तेमाल किया है, और भी हम करने जा रहे हैं, क्योंकि दिल्ली एक ऐसा क्षेत्र है और हमारा विश्वविद्यालय जिस क्षेत्र में स्थापित है वहां धूप हमें बहुत मिलती है। तो हमने अपने रूफटॉप पे बहुत सारे लगाए हैं, और भी योजना है कि हम ज्यादा से ज्यादा रूफटॉप पे उसको लगाएं। एक समस्या ये आ रही है कि, और उसमें मैं चाहूंगा कि सेवाराम जी हमारी मदद करें, कि जो हमारे रूफटॉप्स हैं वो रूफटॉप स्लैंटिंग हैं बहुत, और थोड़ा सा यूरोपियन स्ट्रक्चर लिया है। अगर फ्लैट रूफ्स होते तो हम ज्यादा से ज्यादा वो सोलर पैनल्स लगा सकते थे और उनके मेंटेनेंस में भी सुविधा रहती। लेकिन मैं ये प्लान कर रहा हूं, और मैं ये चाहता हूं कि स्कूल ऑफ इंजीनियरिंग टेक्नोलॉजी सेवाराम जी जैसे और नौटियाल साहब जैसे विद्वानों से संपर्क करके ये देखें कि इग्नू का सर्वे करें, और ये देखें कि कहाँ और पैनल्स लग सकते हैं। हमारे पास कुछ जमीनें भी खाली हैं जिसमें खेती होती है, तो क्या फूल उगाए जाते हैं, सब्जियां उगाई जाती हैं। अब देखिए, पानी की कमी के वजह से हम लोगों ने सब्जियों का उगाना थोड़ा कम कर दिया। तो क्या कोई ऐसा प्रावधान हो सकता है कि कम पानी का इस्तेमाल करते हुए हम कुछ सब्जियां उगाएं, कुछ ऐसे पेड़ पौधे लगाएं जिसमें कम पानी लगता। अभी मैं कल ही एक बैठक कर रहा था जिसमें 3 या 4 सीवरेज ट्रीटमेंट प्लांट्स को पुनर्जीवन देने की बात की मैंने, क्योंकि एक आप लोगों को मालूम होगा कि हमारे जहां पर विश्वविद्यालय स्थापित है उससे ऊपर की ओर मैदानगढ़ी गांव है, और वहां से जो पानी गिरता है, आता है, वेस्ट पानी जो आता है, यूज्ड वाटर जो आता है, वो हमारे विश्वविद्यालय के अंदर आता है। हम लोगों ने उसको बाहर निकालने की तो व्यवस्था कर दी है, लेकिन उसकी विडंबना ये हुई है कि जो वो पानी बाहर निकलता है, तो उस जहां से बाहर निकलता था वो पानी, वहां पर एक रिजर्वायर हुआ करता था, तालाब जैसा हुआ करता था, और वो पानी वहां जमा होता था और उसका उपयोग सिंचाई के लिए लोग किया करते थे। लेकिन हुआ ये कि काफी जब जनसंख्या बढ़ जाती है तो गांव में भी और शहरों में भी लोग जो वो छोटे छोटे तालाब होते हैं, गढ़ी होती है, उसको भरने लगते हैं, और भरने के बाद वहां मकान बनाने लगते हैं। तो वो पूरा जो रिजर्वायर था वो भर गया है और लोगों ने मकान बना लिया। तो होता है कि ये जो पानी उधर जाता है तो वो लोगों के घर के आगे फैल जाता है। तो मैंने एक CPWD के इंजीनियर्स को बुलाया और उनसे ये कहा कि देखिए, हमारे अंदर जो पानी जनरेट होता है इग्नू के कैंपस में, उसके लिए तो हम लोग इंतजाम कर रहे हैं, और उसके वो चूंकि हमारा STP थोड़ा पुराना हो गया है तो नया STP हम लगा रहे हैं। लेकिन इसके बारे में भी सोचिए, ये जो पानी गांव के बाहर से आ रहा है और वो दूसरे गांव में जाके गिर रहा है हमारे विश्वविद्यालय, तो क्या हम इसको टैप नहीं कर सकते हैं इस पानी को, और इस पानी को हम यहीं रख लें, उसको ट्रीट कर दें, और ट्रीट करने के बाद उसको सारे के सारे सारा पानी हम हॉर्टिकल्चर को दे दें पानी, तो क्या होगा कि हॉर्टिकल्चर जो पानी उपयोग में लाता है, वो ग्राउंड वाटर जो पानी है, उस ग्राउंड वाटर के पानी का इस्तेमाल नहीं करे। क्योंकि क्या हुआ है कि ग्राउंड वाटर के पानी का इस्तेमाल करने के कारण पानी खारा हो गया है और आसपास के इलाकों में जल की कमी भी हो गई है। अभी मैं एक सीरियल देख रहा था, गिल्टी माइंड्स, उसमें इसी पर एक बहस होती है, विकास और किसान। और ये वो बहुत अच्छे तरीके से कोर्ट के सीन के माध्यम से ये सारे मुद्दों को उठाते हैं। वहाँ एक प्लांट है और जो पेय पदार्थ बनाता है और वो पानी का इस्तेमाल ज्यादा करने लगा है, इसलिए किसानों के नलकूप सूख गए हैं, किसानों के कुएं सूख गए हैं और किसान को फसल में पानी नहीं मिल रहा है। तो एक विकास हम करें, लेकिन इस बात का हम ध्यान रखें कि देखिए, आज हम कहते हैं कि हम खाद्यान्न और भोजन के मामले में हम सेल्फ सफिशिएंट हैं और हम ये कहते हैं कि हम जो रूस और यूक्रेन का जो युद्ध हो रहा है, उस युद्ध के कारण हम अंतर्राष्ट्रीय बाजार में गेहूं की कमी हो गई है, तो हम गेहूं के निर्यात के लिए सक्षम हैं। तो अभी इस दिशा में और कार्य करना है, क्योंकि अभी तक जो हमारे किसान हैं, उन किसानों को जो कृषि क्षेत्र में जो परिवर्तन हो रहे हैं, अभी एक नौटियाल साहब ने एक बासमती चावल की बात की थी कि बासमती चावल का जो उपयोग हो रहा है उसमें कुछ ऐसे चावल भी हैं जो बासमती नहीं है और उसका किस तरह से डीएनए टेस्ट किया गया। किसानों को भी ये बात बताई जानी चाहिए कि देखिए, आप जो बासमती चावल या जो भी आप उपजा रहे हैं, वो मानक पर खरा नहीं उतर रहा, तो किसान भी सावधान होगा, उसको भी। तो ये सारे जो प्रयोग हैं वो पंचायतों के माध्यम से गांव में भी जाने चाहिए। मेरा केवल यही कहना है कि प्रौद्योगिकी का इस्तेमाल केवल युद्ध के लिए ना हो, बल्कि शांति के लिए हो और आर्थिक समृद्धि के लिए हो। और ये तभी होगा भारत जैसे देश में जब हम दूर दराज के क्षेत्रों में पहुंचेंगे, जब हम किसानों के पास पहुंचेंगे और जितना ज्यादा उपज होगी और किसानों को ये बताएंगे कि जहां पानी की कमी है वहां कौन से फसल उगाए जाने चाहिए। देखिए, सबसे ज्यादा पानी जो लगता है वो कपास में लगता है और चावल में, धान में लगता है। कैसे उसको बैलेंस करें, क्योंकि हम चावल खाते हैं, कपास का उपयोग करते हैं, लेकिन उसको बैलेंस कैसे करें। तो इसलिए ये सारी बातें भी हमारे वैज्ञानिक सोच रहे हैं। हरित क्रांति भी आई, लेकिन हरित क्रांति एक सीमित क्षेत्र में आई। मैं आपको बताना चाहूंगा कि जो पूर्व के राज्य हैं हमारे, वहां तक अभी भी हरित क्रांति का पूरा लाभ नहीं मिला है। किसानों की उपज जहां जहां हरित क्रांति हुई, वहां की अपेक्षा वहां प्रति एकड़ कम हो रही है। तो हमें उस ओर भी ध्यान देना चाहिए। बहुत सारे इलाके हैं, मैं बिहार का रहने वाला हूं, मैं देखता हूं बिहार में लोगों को खेती करते हुए, और ये देखता हूं कि कई बार तो एक फसल में ही वो संतुष्ट हो जाते हैं, ज्यादा से ज्यादा 2 फसल लेते हैं, क्योंकि उनके पास वो प्रौद्योगिकी नहीं पहुंची है कि कम लागत में और कम श्रम से अधिक उत्पादन कैसे हो सकता है। तो हमारा देश कृषि प्रधान देश है, आज भी कृषि प्रधान देश है, और अगर हम अपने कृषि को समृद्ध बनाते हैं, गांवों को समृद्ध बनाते हैं, तो ये जो दिल्ली और कलकत्ता और बंगाल, कलकत्ता और मुंबई, बेंगलोर जैसे शहरों में जो मजदूरों का जो पलायन हो रहा है, जरूरत है इंडस्ट्री को, मजदूरों की भी। लेकिन अगर हम अपने गांव को सेल्फ सफिशिएंट बनाते हैं तो ये पलायन नहीं होगा और काफी लोगों को गांव में भी नौकरी मिलेगी, गांव में भी काम मिलेगा। लेकिन इसके लिए बहुत काम करने की जरूरत है। केवल ये ऐसा नहीं कि केवल दिखाने के लिए ही अखबारों में और पेपर पर ये रह जाए, बल्कि बहुत जमीनी स्तर पर काम करने की जरूरत है। काम हो भी रहा है, लेकिन उस ओर ज्यादा ध्यान देने की जरूरत है। मैं ये नहीं कह रहा हूं कि हमारे यहाँ मेट्रो आर्टिफिशियल इंटेलिजेंस से न चले, ट्रांसपोर्टेशन में वो गतिविधि ना आए कि ऑटो ड्राइवर से ही वो काम चल जाए। लेकिन इसके साथ साथ हमें गांवों की ओर भी देखना पड़ेगा। इंडस्ट्रीज, उद्योग और किसान, उद्योग और मजदूर, इन दोनों के बीच में जब तक हम सामंजस्य स्थापित नहीं करेंगे तब तक गांव और शहर का आर्थिक मामलों में, सामाजिक मामलों में बहुत फासला बढ़ेगा। इसलिए आज के राष्ट्रीय प्रौद्योगिकी दिवस के अवसर पर हमें ये बात करनी चाहिए कि जो पिछड़े हुए इलाके हैं, जो ग्रामीण इलाके हैं, उनको कैसे ये जो नौटियाल साहब और सेवाराम जी जो कार्य कर रहे हैं, उनका लाभ ग्रामीण संस्थानों को, गांवों को, पंचायतों को किस प्रकार मिले। बिजली नहीं मिलती है लोगों को, किस तरह से सोलर एनर्जी जिसकी बात की गई थी, उसका ज्यादा से ज्यादा उपयोग हम गांवों में करें। गांव में, भारत के गांवों में धूप बहुत मिलती है, हमारे पूरे देश में धूप बहुत मिलती है। तो अगर हम ये कर देंगे सोलर एनर्जी के रूप में, तो फिर जो कोयले से जो ज्यादातर हम लोग एनर्जी बनाते हैं, अभी देखिए बिजली का संकट आ गया था, कोयले की कमी हो गई थी, तो उस संकट से हम मुक्त हो सकेंगे। और जो प्रकृति का जो अवदान हमारे पास है, सूरज है, जल है, जल का इस्तेमाल हम बिजली उत्पादन में करते हैं, सूरज का भी करते हैं। लेकिन सूरज एक अक्षय स्रोत है, पानी तो कम भी हो जाता है। सूरज की जो रोशनी हमारे ऊपर पड़ती है, वो रोशनी दिन भर में हमारे प्राण रक्षा तो करती ही है, लेकिन उसका पूरा उपयोग हम नहीं कर पाते हैं। और बिजली का उपयोग अगर सौर ऊर्जा से हम करते हैं तो सबसे ज्यादा फायदा हमारे गांवों को होगा, जहां फिर बिजली पहुंचाने के लिए हमें अतिरिक्त उत्पादन नहीं करना पड़ेगा। हर एक पंचायत में हो, हर एक जो सिंचाई के लिए मोटर पंप्स का इस्तेमाल करते हैं, वो संचालित हो सौर ऊर्जा से। तो ये सौर ऊर्जा पर अभी हमें और भी ध्यान देने की जरूरत है, और इसकी उपयोगिता शहर से ज्यादा गांव की है, ये मैं कहना चाह रहा हूं। तो आज हमारे जो उपादान हैं, हमारे जो प्रयोग हैं, हमारे जो वैज्ञानिक उपलब्धियां हैं, उसका लाभ कैसे गांवों को ज्यादा से ज्यादा मिले। तो ग्रामीणोन्मुख प्रौद्योगिकी और विज्ञान की ओर हम लोगों को ध्यान देना चाहिए। और अगर हम ऐसा करते हैं तो हम एक बहुत मजबूत राष्ट्र बनेंगे और आर्थिक रूप से और संपन्न होंगे। और जितना ज्यादा हम अनाज उपजाएंगे, आत्मनिर्भर होंगे, उतने ही हम मजबूत होंगे। देखिए, ये आधारभूत आवश्यकता है। बाकी ये आर्टिफिशियल इंटेलिजेंस से गाड़ी तो हम चला लेंगे, लेकिन हमारे पास भोजन नहीं होगा तो ये सब बेकार है। तो इसलिए, और ज्यादा से ज्यादा जिस तरह से फर्टिलाइजर्स का हम उपयोग कर रहे हैं, उसका उपयोग कैसे कम कर सके, कैसे जैविक खेती हम लोग कर सकें और उत्पादन भी बढ़ा सकें। ऐसा नहीं है कि तो एक ऐसी टेक्नोलॉजी विकसित होनी चाहिए, और वो भी रही होगी, मेरी जानकारी में नहीं है, कि जैविक खादों का उपयोग कर हमारे यहाँ जिस तरह से परंपरागत रूप से हम गौ माता की सेवा करते हैं, बहुत सारे उपादान उससे मिल सकते हैं जैविक खेती के लिए। हमारे पास अभी जो बछड़े होते हैं, उन बछड़ों की उपयोगिता धीरे धीरे खत्म हो गई है, क्योंकि ट्रैक्टर्स आ गए हैं और हल से उस तरह से खेती। उनका उपयोग हम कैसे कर सकते हैं अपने राष्ट्रीय उपयोग में और प्रौद्योगिकी में, उन किस तरह, ये सारी चीजें सोचनी होंगी और ये हमारे वैज्ञानिक सोच रहे हैं। मैं एक साहित्य का विद्यार्थी हूं और एक श्रोता हूं। मेरे दिमाग में जो बातें आई आदरणीय नौटियाल जी को और सेवाराम जी को सुनते हुए, क्योंकि सेवाराम जी ने बहुत पीछे ले गए हम लोगों को, हड़प्पा और मोहनजोदड़ो में भी ले गए, पूरे सिंधु घाटी सभ्यता की बात की, वैदिक युग की बात की। हर एक सभ्यता और हर एक संस्कृति एक वैज्ञानिक और प्रौद्योगिकी का कार्य करती है, उसके बिना वो रह ही नहीं सकते हैं, कोई सभ्यता विकसित हो ही नहीं सकती। तो बहुत ही बेहतर ढंग से परंपरा और आधुनिकता दोनों को समझाते हुए सेवाराम जी ने और नौटियाल जी ने हम लोगों का ज्ञान वर्धन किया। और इस अवसर पर जब हमारे लाखों विद्यार्थी इस कार्यक्रम को आज सुन रहे हैं या कल सुनेंगे, क्योंकि इसे हम विभिन्न चैनल्स पर भी प्रसारित कर रहे हैं और निश्चित रूप से ये रिकॉर्डिंग भी हो रही है, जिसे बाद में भी हम प्रसारित करेंगे, ताकि लोग ये समझ सकें कि किस तरह से इस राष्ट्रीय प्रौद्योगिकी दिवस का हमें इस्तेमाल करना चाहिए। मैं एक बार पुनः अपने दोनों विद्वान मित्रों सीएम नौटियाल साहब और सेवाराम जी को नमस्कार करता हूं। अपने कुलपति को मैं प्रणाम करता हूं कि उनकी प्रेरणा से इस तरह के कार्यक्रम विश्वविद्यालय आयोजित करता है। और हमारा जो स्कूल है, स्कूल ऑफ इंजीनियरिंग एंड टेक्नोलॉजी, वो एक बहुत ही सशक्त स्कूल है। मैं आपको बताना चाहता हूं कि हमारे सारे शिक्षक आईआईटी से प्रशिक्षित हैं, पीएचडी प्राप्त की है, उनके पास बहुत ही गुणवत्ता है। बस मैं ये चाहता हूं कि उनकी गुणवत्ता जो है वो दिखे और ये न समझे कि केवल कोर्स मटेरियल ही तैयार। आपके अंदर असीम क्षमता है और प्रेरणा लेनी चाहिए आपको नौटियाल साहब से और सेवाराम जी से कि वो किस तरह से राष्ट्रीय उत्थान की दिशा में काम कर रहे हैं। आपको भी राष्ट्रीय उत्थान की दिशा में काम करना चाहिए, नए प्रयोग करने चाहिए, अपनी क्षमता का विस्तार करना चाहिए। और मैं सभी जो लोग भी इस कार्यक्रम को सुन रहे हैं, देख रहे हैं, सबको मैं नमस्कार करता हूं और मैं बहुत कृतज्ञ हूं कि आपने मुझे अपने साथ शामिल किया और मुझे 2 शब्द कहने का मौका दिया। बहुत बहुत धन्यवाद, शुक्रिया।
बहुत बहुत धन्यवाद सर आपके इस उत्कृष्ट उद्बोधन के लिए। और निश्चित रूप से सर आपके मार्गदर्शन में हम आगे रिसर्च एंड डेवलपमेंट में भी आगे बढ़ेंगे और इस तरीके की रिसर्च पे फोकस करेंगे जो ग्रामीण अंचलों में अपना प्रभाव बना सके, ग्रामीण अंचलों में और आर्थिक रूप से उन लोगों को सशक्त बना सके और निश्चित रूप से वो हमारे लिए भी उतना ही उपयोगी हो। धन्यवाद सर। इसी के साथ सर मैं अनुमति चाहती हूँ कि अब इस फोरम को ओपन कर दिया जाए ताकि सारे पार्टिसिपेंट्स डिस्कशन कर सकें। अनुमति दें।
श्वेता प्लीज। सर बिल्कुल जैसा सचिन सर ने सर 1 मिनट है, वह बात करना चाहता हूँ मैं। सर बिल्कुल आप जैसा बात किया सर, हम लोग का इंडिया में ग्रामीण तत्व में बहुत ज़रूरी है। जैसा आपने बोला है ये जो सौर शक्ति, तो उनका काफ़ी रिसर्च की भी ज़रूरत है सर। अभी तो जो सेल्स वगैरह आ रहा है वो इवन कुछ फ्लेक्सिबल मटेरियल में भी आ सकता है। अगर हम लोग रिसर्च करें उस तरह में, उस तरीके की रिसर्च हम लोग पेटेंट करके उनको दे दिया जाए तो फ्लेक्सिबल वे में बहुत सस्ता में हम लोगों को उनको उपलब्ध किया जा सकता है सर। बिल्कुल उसी तरीके की सेम चीज़ है हम लोग को, जैसा लो कास्ट हाउसिंग सर, हाउसिंग में लो कास्ट हाउसिंग में काफ़ी काम हो चुका है, उसको लेते हुए हम लोग एक्सटेंड करके जैसा हम लोग का 5 में डिवाइड हो जाते हैं सर। जो वातावरण का जो वेदर कंडीशंस है सर, ह्यूमिड वेदर है, एरिड वेदर है, हॉट एंड ह्यूमिड है, इस तरीके की जो है उनका जो प्लानिंग्स है, डिफरेंट प्लानिंग्स करके काफी कम में बिजली सेव करते हुए हम लोग उनको कंफर्टेबिलिटी प्रोवाइड कर सकते हैं सर। इस तरीके की चीजों में हम लोग है स्कूल ऑफ इंजीनियरिंग टेक्नोलॉजी बिल्कुल करना चाहता है सर। हम लोग ने काफी काम किया है एरियर में भी, इवन 90s में हम लोग ने ट्रेनिंग दिया था इवन बारबेंडर्स को, प्लम्बर्स को, इवन कंस्ट्रक्शन सुपरवाइजर्स को। इवन हैदराबाद में सर एक्चुअली जब 96 में हम गए थे वहां पर एलएनटी में हम लोग काफी लोगों को शिक्षित किया था। वो एक्सटेंड कर सकता है, हम लोग अच्छी तरह से बना सकता है। हम बिल्कुल इस तरीके सर करके, इग्नो का नाम है हम लोग को पूरा देश में प्रचलित हो, उसके लिए थोड़ा सा रिसर्च फैसिलिटीज भी हम लोग को थोड़ा बहुत चाहिए सर, बहुत ज्यादा नहीं चाहिए सर। जो उनके लिए जो जो चाहिए उनको अगर इग्नो अगर हम लोग को प्रोवाइड करे, हम लोग को थोड़ा सा रिसर्च स्टूडेंट्स भी मिल जाए, हम लोग उसके हिसाब से हम लोग है थोड़ा बहुत इसको एक्सटेंड करके, जैसा आपने बिल्कुल सही कहा है पेटेंट लेना चाहिए था। दीज आर ऑल पेटेंटेड इश्यूज सर। एक्चुअली हम लोग जब रिसर्च करेंगे तो आप बिल्कुल सही कह रहे हैं, एप्स बना सकते हैं, जैसा डिफरेंट प्लान्स का एप्स बना सकते हैं सर, जो बिल्कुल है वो उस वेदर के लिए कैसा चाहिए वो उस तरीके की प्लानिंग बना सकता है। उसको बिल्कुल जैसा डेटा दे दे, वो डेटा देने से उनको बिल्कुल जिस तरीके की ओरिएंटेशन होना चाहिए था, जिस तरीके की वॉल होना चाहिए था, ये सब है उनकी हाथ पे आ जाए तो इवन आम जनता है वो यूज करे, उस तरीके की हम लोग है सोच सकते हैं, उस तरीके के पेटेंट के लिए हम रिसर्च कर सकते हैं। थोड़ा सा रिसर्च की हम लोग का सब थोड़ा सा फैसिलिटीज मिल जाए, आपने काफी हेल्प किया है हम लोग को स्कूल ऑफ इंजीनियरिंग टेक्नोलॉजी को, और थोड़ा सा इसका भी थोड़ा सा हेल्प एक्सटेंड हो जाता है तो हम लोग काफी आपकी आभारी है सर। हम लोग करके दिखाएंगे सर। हम लोग एज यू सेड इट, हम लोग का आईआईटी का पीएचडी प्रोडक्ट्स है यहाँ पर, हम लोग बिल्कुल सक्षम है सर, हम लोग इंथुजियास्ट भी है उस तरह के करने के लिए। सो आई थिंक बहुत अच्छा बोला सर, बहुत अच्छा आपने बिल्कुल इंटीग्रेट किया है। I think we are happy. I think today is technology day. I think we are discussing all these things. बहुत अच्छा लगा सर मुझे। I think बाकी की भी डिस्कशन पे आ जाए तो अच्छा है। तो थैंक यू सर, थैंक यू सत्यकाम सर, प्लीज।
अजीत सर माइक ऑफ है, अजीत सर माइक ऑफ है।
हाँ जी आ रही है, बोलिए बोलिए अजीत जी। हाँ जी आ रही है अजीत जी, बोलिए।
सर आवाज नहीं आ रही है।
हमको आवाज आ रही है।
अच्छा आपको आ रही है?
हाँ
अच्छा फिर ठीक है सर।
जी जी अजीत जी आ रही है।
हमको नहीं मिल रहा आवाज अजीत जी, भरद्वाज कैसा है?
आ रहे हैं हम तो।
टेक्निकल कुछ इश्यू है।
नहीं आ रही है, मुझे तो आ रही है कंटिन्यूअसली सर शुरू से ही।
बाकी को आ रहा है, सुनाई दे रहा है अजीत जी का जो आवाज है?
अभी अजीत जी को हमने इधर बुला लिया है, अभी 1 मिनट में आ ही रहे हैं वो।
बोल लीजिए
सर। आ गए।
हाँ, आवाज आ रही है?
हाँ बिल्कुल आ रही है सर, बिल्कुल आ रही है सर।
ठीक है। तो मैं ये कह रहा था, मैं धन्यवाद देना चाहता हूँ कि जो दोनों स्पीकर्स थे, नौटियाल साहब और सेवाराम जी, इन्होंने कई सारी जानकारी दी और बहुत कुछ बताया कि टेक्नोलॉजी ने, और बताया कि साइंस एंड टेक्नोलॉजी कैसे साथ साथ चलते हैं, और इन्होंने क्या अचीवमेंट किया है लेंथ और ब्रेड्थ में। इसके साथ में एक चीज़ और ऐड करना चाहता हूँ कि एक जो प्रजातांत्रिकरण होता है, डेमोक्रेटाइजेशन होता है, कि टेक्नोलॉजी को आम आदमी तक, सामान्य लोगों तक पहुंचाना, या किसी भी उपलब्धि को, तो ये भी काम टेक्नोलॉजी ने बखूबी किया है, जिसमें एज सच कहा जाता है कि कोई नयापन तो नहीं है, लेकिन वो लोगों तक पहुंचा है, और वो हमारी एक उपलब्धि है जो आज हमें हासिल है। जैसे कि अब आप एग्जाम्पल ले शैम्पू का ही, तो कभी ये बड़े लोग यूज़ करते थे, जब शैशे का आविष्कार हुआ तो वो चीज़ आम आदमी तक पहुंच गई, सब तक पहुंच गई। या आज हम एजुकेशन की बात करें अपने फील्ड में, तो एक समय सेवाराम जी के लेक्चर्स केवल SPA में लोग सुन सकते थे। आज दुनिया में कोई भी व्यक्ति, कोई भी स्टूडेंट जो चाहता है कि जिसकी ट्रांसपोर्टेशन में इच्छा है और जो इनके लेक्चर सुनना चाहता है, वो सुन करके उससे लाभान्वित हो सकता है, चाहे वो चिरकुट इंस्टीट्यूट ऑफ टेक्नोलॉजी में क्यों ना पढ़ता हो। तो ये एक बहुत बड़ी सुविधा है जो एक सामान्य स्टूडेंट को मिल जाती है, और हम लोग उस युग में हैं क्योंकि हमने वो समय देखा है जबकि क्यूरिकुलम रिवाइज करने में कुछ यूनिवर्सिटीज़ को, जब मैंने यहाँ ज्वाइन किया था तो लोगों ने बताया कि 30 साल लग जाते हैं, जबकि हमारे यूनिवर्सिटी की अच्छाई ये है कि हम 10 साल में अपने क्यूरिकुलम रिवाइज कर लेते हैं। पर आज वो समय और घट गया है और हम काफ़ी तेज़ी से काम को कर लेते हैं, और जो भी नई टेक्नोलॉजी है और जो भी नई चीज़ है उसको हम क्यूरिकुलम में शामिल कर लेते हैं। दूसरी बात, जो एक अच्छी बात PVC ने कही, नेचुरली ऐसे लेक्चर्स और ऑर्गेनाइज होने चाहिए कि ग्रामीण क्षेत्रों में और सोलर एनर्जी के क्षेत्रों में काफ़ी काम हुआ है, हम लोग को जानकारी नहीं रहती है। तो मैं आग्रह करूँगा अपने डायरेक्टर से और श्वेता से कि वो इन क्षेत्रों में भी कुछ इनवाइटेड लेक्चर्स ऑर्गेनाइज करें।
बिल्कुल सर।
एक अच्छी बात उन्होंने ये कही है कि हम लोग को भी कुछ करना चाहिए प्रेरणा लेकर के। तो निश्चित ही हमें पूरा विश्वास और उम्मीद है, और जैसा करते भी रहे हैं कि मैनेजमेंट, VC साहब और PVC साहब इसकी सुविधा हम लोग को निश्चित प्रदान करेंगे। क्योंकि मैंने एक प्रोजेक्ट में काम किया था, यहीं रहते हुए 2 साल पहले तक मैं एक्टिव था। IIT दिल्ली से भारत उन्नत अभियान के अंदर मैं PI था, और मैंने उसकी बात उन्होंने की, बछड़ों की बात की। तो एक रूरल टेक्नोलॉजी में एक मशीन के ऊपर मैं काम कर रहा था, जिसमें कि बुलॉक ड्रिवन ट्रैक्टर के ऊपर काम हो रहा था। तो उसमें जिस पार्ट का मैं PI था, उसमें एक मशीन डेवलप करनी थी कि जब एग्रीकल्चरल इम्प्लीमेंट पीछे लगा हो और बुलॉक चल रहा हो, तो उसको कैसे जहां जरूरत पड़े ऊपर उठा लिया जाए और फिर जहां जरूरत पड़े उसको जितनी गहराई तक जमीन में हम ले जाना चाहें वो जा सके, जैसा कि ट्रैक्टर्स में होता है। तो मैंने वो सिस्टम डेवलप किया और वो सक्सेसफुल रहा, उसको अप्रिशिएट भी किया आईटी दिल्ली के डिपार्टमेंट ने। तो वो मैंने देखा कि इग्नू में भी उसका ब्रांच है, पर वो मुझे पता नहीं चल सका कि कहाँ पर है। तो निश्चित ही एक प्रोजेक्ट में मैं, श्वेता और शशांक काम कर रहे थे कि बच्चों से एनर्जी कैसे जनरेट की जाए, और उसके लिए कुछ आधा अधूरा काम हमने गोवर्धन मथुरा में किया भी था इक्विपमेंट पर, लेकिन वो मेरी बीमारी की वजह से वो काम छूट गया। तो अब मैं निश्चित ही उम्मीद करता हूं, जब पीवीसी ने खुद कहा है कि इस क्षेत्र में काम करने की सुविधा हम लोग को मिलेगी, और उस प्रोजेक्ट को मैं फिर से शुरू करता हूं कि उस प्रोजेक्ट को आगे बढ़ाया जाए। और इसके लिए मैं बहुत बहुत धन्यवाद देता हूं पीवीसी साहब का कि उन्होंने हमें प्रोत्साहित किया है ऐसे काम करने के लिए। और मैं ये बताना चाहता था कि उसमें हमारी भी इच्छा है कि वो जो बछड़े कट जाते हैं और उनका एक कोई यूज़ नहीं रहता है, तो उनसे अगर एनर्जी जनरेट कर ली जाए तो बहुत सारी गौशालाओं को मैं जानता हूँ जहाँ की 5-5 हजार 6-6 हजार केवल बैल हैं, और नंदी गौशाला उनको कहते हैं, और वो इंतजार कर रहे हैं कि इनका हम कैसे उपयोग करें ताकि इनकी एक्सरसाइज भी हो और उससे कुछ हमें लाभ भी हो, और वो केवल इकोनॉमिकल लायबिलिटी बन के न रह जाए। धन्यवाद।
धन्यवाद सर।
धन्यवाद सर। कोई और पार्टिसिपेट करना चाहता है तो कर सकता है। I think, sir, we should now conclude the webinar. So I would like to request Professor K.T. Mandan, sir, to present a formal vote of thanks.
Thank you, Sweta. Good afternoon to all. On behalf of organizing team, School of Engineering and Technology, it's a great honor and my privilege to propose vote of thanks on this memorable and special occasion on National Technological Day. And first and foremost, I thank our Vice Chancellor, Professor Nageshwar Rao, and beloved Honorable Pro Vice Chancellor, Professor Satyakam, who is providing continuous support and non-stop motivation to all our academic activities. I would like to thank our Director, School of Engineering and Technology, Professor Ashish Agarwal, who is putting continuous effort to development activities of the school. Also, I would like to thank the Director of National Center for Innovation in Distance Education, Dr. O.P. Sharma, and Director, Center for Online Education, Professor Subodh Keshavani, who providing innovative thoughts, ideas, and various supports in different occasions. My heartful and special thanks to our guest on this special occasion on National Technological Day, Dr. C.M. Nautiyal, Consultant, Indian National Science Academy, Delhi, and Professor Sevaram, Head of the Department, Transport Planning, School of Planning and Architecture, Delhi, for their excellent presentation through the valuable inputs and fruitful discussions on this special occasion on National Technological Day. Also, I thank Dr. Sweta Tripathi, the coordinator of this program, who put their valuable effort to success this program. Also, I thank all distinguished participants from various schools, divisions, heads of various schools and divisions and regional centers who are participating in this special occasion during their busy schedule. Last but not least, I thank my colleagues for your cooperation in making this function a resounding success. Thank you. Thank you all.
Thank you very much, sir. And now I would request all of you for the national anthem. After this, the program will be concluded. Shekhar, please play National Anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे।
श्वेता एक छोटी सी चीज बोलना चाह रहे थे।
हाँ सर।
ये हम लोगों ने कार्यक्रम किया है ना, इसमें जो बैक हैंड पे जो हमारा फोर्स है स्कूल में, जैसे शेखर हो गया, संगीता हो गई, मीना जी हो गए, बलवंत हो गया, राजेंद्र हो गए, है ना, और इन सब का भी सपोर्ट बड़ा रहा। तो इन सबको भी मैं कोऑर्डिनेटर की तरफ से और सब फैकल्टी की तरफ से थैंक्स बोलना चाहता हूँ कि उनका सपोर्ट रहा और उसकी वजह से बैक हैंड पे सारा कार्यक्रम जो है होता रहा है। थैंक यू।
Thank you, sir. And thanks to all the participants. Thank you. Thanks a lot.
Thank you, ma'am. Thank you, sir.
Thank you, sir. Thank you, sir.